Okay, so we are going to do chapter 9, and actually we're only going to do a couple of lessons from chapter 9. I'm going to try to break it up into smaller pieces so it's easier for you to understand. So what are we covering this chapter? We are going to be doing quadratic functions. Okay, and the first lesson we're going to do is on graphing them. So first of all, we've been working with quadratics. That was when we were doing all the factoring and completing the square and all of those different types of solving. So now we're actually going to graph them. So just like how you graph a line, right? When we have, let's say, y equals mx plus b, right? The m stands for something. It means the slope. The b stands for something. It means the y-intercept. So similarly, when we have quadratic functions, these values mean something. So a quadratic, just remember, is anything that has an x squared, basically. All right, so any function that has an x squared. So the shape is called a parabola. So if you see here below, it's kind of a U shape. So anytime you have an x squared, okay, it's going to have either the U shape, and it could be wider or skinnier. It could be upside down, okay. Below is what we call our parent function, which is just our basic y equals x squared with no other values, okay? We have what is called a vertex, is at 0, 0. So think of that as like our starting point, okay, or where the bottom of that U would be. And then we also have something called the axis of symmetry, which is y equals 0. So our axis of symmetry is the line that goes right through. So imagine if we were able to fold our paper along that that line I just drew, the function would map onto itself. In other words, symmetrical. So whatever I have on the left side, I can also find on my right side. Now what we're going to do is we're going to graph these using a table of values, okay, which we did when we first started graphing lines, and then I showed you some other methods. So just a quick show here. So x is equal, right? X is what we're going to figure out what values to plug in. And my y is x squared. So if I were to just work with some of these values, so like if I plugged in -2, -2 squared would give us 4. So if I look on my graph, -2, 4, that's a point right on that graph. If I plug in -1, I square it, I get +1. So you'll notice the point -1, 1 is right there. 0, 0. So of course when I square 0, I get 0. That was my vertex. When I square 1, I get 1. So 1, 1. And when I square 2, I get 4. Notice what I got here, I got here. What I got here, right, for the y value, I got here. And then that vertex is right in the middle. So when we create our table of values, I'm going to be very particular with how I want you to set it up. Okay, so graphing quadratic functions. I'm going to take you step by step, and then we'll do some examples. Okay, so first thing, I want you to identify the values of the coefficients a and b in the equation, because what we want to do is we want to figure out what is the vertex. What is that middle point? Okay, that's going to be key. So the way we find the vertex is we have to identify the values of a and b. So here's an example, x squared minus 4x plus 3. So a, if there's nothing in front, that means that coefficient is a 1. And then the second coefficient, b, okay, so a is always what's in front of x squared, b is always what's in front of x. So we want to find the x coordinate of the vertex using the formula x equals -b over 2a. All right, so with my example, -b, so negative, but then b is already negative, so I'm going to put a negative in front of the negative, divided by 2 times a, which is 1. Again, I'm using that formula. So the negatives will cancel, so I get 4 over 2, which equals 2. So this is the x coordinate of my vertex. All right, so what I'm going to do, and when you see the homework, right, I'm going to have these tables for you. All right, so using a table with five rows, place the x coordinate in the middle row. So you'll notice I already placed it there for you. Okay. Step 4, with the vertex in the middle, pick 2 smaller values and 2 larger values evenly distributed. So basically what I do from the 2, I subtract 1, subtract 1. So that's why I have a 0 and then a 1. And then I add 1 and then add another one. I want all these numbers to go in order and I want them to be evenly distributed. Okay, so setting up your table is probably the most important thing when you're graphing these quadratic functions. Now, the next step is to actually find the points. So remember, this was our function we were working with, y equals x squared minus 4x plus 3. We're going to substitute in, so I have 0 squared minus 4 times 0 plus 3. Well, that's going to give us 3. So 0, 3 is our point. Next, we're going to plug in 1. So we have 1 squared minus 4 times 1 plus 3. And you can use your calculator if you need to here. But this one, let's see. So 1 minus 4 plus 3 is what we have. So that's going to just give us 0. So that's going to be the point 1 comma 0. We have 2 squared minus 4 times 2 plus 3. Again, I'm just plugging into that function above. So 2 squared minus 4 times 2 plus 3 gives me a negative 1. So 2, negative 1. Here, 3 squared minus 4 times 3 plus 3. So that's going to be 9 minus 12 plus 3, which is 0. Now, notice if I set up my table correctly, the y coordinates should have symmetry, so to speak. So notice when I plugged in 1, I got 0. When I plugged in 3, I got 0. So when I plug in 4, I should get 3. So let's see. 4 squared minus 4 times 4 plus 3. So that's going to be 16 minus 16 plus 3. Perfect. So I get 4, 3. Again, these should be the same value. These should be the same value, and the vertex should be something different. The vertex is the one right in the middle. Next, and this is the last part, is we're going to use the ordered pairs. So we're going to plot these points. Okay, so 0, 3 goes here. 1, 0. 2, negative 1. And 3, 0. And 4, 3. Connect the dots using a curved line. So remember how I said a parabola is a curved line. It's not a straight V. So we're just going to kind of connect them. We are going to put arrows on the ends because it does continue on to infinity. And I'm just going to label, the vertex is 2, negative 1. Okay, so we're going to go through the steps again. First thing I want to do, remember, ax squared plus bx plus c. So I want to identify a is 1 and b is 6. So I want to find the x coordinate of the vertex. The x coordinate of the vertex was, remember, it was negative b over 2a. So negative b, so that's going to be negative 6 over 2 times 1, which is negative 3. So I'm going to put that right in the middle. Next, what I want to do is I want to count backwards. So, or I want to basically have 2 smaller values. So I'll go negative 4, negative 5, and then I'm going to add 1, so that'll be negative 2, negative 1. Next, I want to use y. Now remember, y in this case is x squared plus 6x. So now I'm going to substitute each of these values into that formula. So I have negative 5 squared plus 6 times negative 5. So don't forget, when you square a negative, it becomes positive. So I get positive 25 minus 30 gives me negative 5. So I have negative 5, negative 5. Plug in negative 4. So I have negative 4 squared plus 6 times negative 4. That'll give me a positive 16 minus 24, which is negative 8. So I have the coordinates negative 4, negative 8. Next, I have negative 3 squared plus 6 times negative 3. So negative 3 squared, that'll be a positive 9 minus 18, which is a minus 9. So that's negative 3, negative 9. Negative 2 squared plus 6 times negative 2 will give us a positive 4 minus 12, which is negative 8. So I have negative 2, negative 8. Negative 1 squared plus 6 times negative 1. So that'll be a positive 1 minus 6, which is negative 5. So I have negative 1, negative 5. So now I have negative 5 there. Negative 4, negative 8. Negative 3, negative 9. Negative 2, negative 8. And negative 1, negative 5. And your points should, that actually didn't look very, there we go. And identify and label the vertex. So that was negative 3, negative 9. Okay, so here A is 1, B is negative 8, so I want to find the x coordinate of the vertex. So that's negative B, so it'll be the opposite of negative 8 over 2 times A, which is 1. So that'll be a positive 8 over 2, which is 4. So I want to put that 4 here. I'm going to subtract 1, add 1, add 1. Again, I want to just make sure all the numbers go in order. And now I'm going to substitute into this x squared, right? So now we're using x squared minus 8x minus 3. So I have 2 squared minus 8 times 2 minus 3. So that will give us 4 minus 16 minus 3. Negative 15, this is going to go off our graph a little bit. So we have 2, negative 15, 3 squared minus 8 times 3 minus 3. So this will be 9 minus 24 minus 3. So this will be a negative 18. Then we have 4 squared minus 8 times 4 minus 3. So that'll be 16 minus 32 minus 3, which is negative 19. And we have 5 squared minus 8 times 5 minus 3. So 25 minus 40 minus 3. So that's negative 18. And then we have 6 squared minus 8 times 6 minus 3. And we get negative 15. So this was all going to go off our graph. So we'll try to make it the best we can. So let's see. So what I'm going to do, I think I'm just going to extend this line to make this. We have, that'll be negative 11, 12, 13, 14, negative 15, 16, 17, 18, 19, 20. So that'll be negative 20. Now we can kind of fit this on our graph as best we can. Let's see. So we have 2, -15. So that's about here. We have 3, -18. So that'll go here. 4, -19. 5. I could probably go over a little bit more. It's kind of hard to fit it all on here. And then 6. And so there's our graph. And the vertex is for -19. Okay, next page we have A is -1 and B is 4. So the x coordinate of the vertex is -b, so it's going to be -4 over 2 times A, which is 2 times -1. So we actually have a -4 over -2, which is a +2. So subtract 1, add 1, add 1, and substitute in. So again, you can use, when you're doing the table of values, just have your calculator next to you. You don't have to do a lot of this by hand. So if I plug in 0, we'll have 0 squared plus 4 times 0. So we'll actually get a -1. So 0, -1. Plug in 1, so that'll be -1 squared plus 4 times 1 minus 1. So that'll be -1. Now notice this is not in parentheses. So when the negative is on the outside, we keep that value negative. So it's going to be -1 plus 4 minus 1. So I get 2. -2 squared plus 4 times 2 minus 1. So that's going to be a -4 plus 8 minus 1, which is 3. So I get 2, 3. I get -3 squared plus 4 times 3 minus 1. So that's going to be -9 plus 12 minus 1. I get 2. And then last, we get -4 squared plus 4 times 4 minus 1. So I have -16 plus 12 minus 1. Or sorry, -16 plus 16 minus 1. So we get -1. So 4, -1. Let's go ahead and graph it. So 0, -1 goes here. 1, 2 here. 2, 3. Then I have 3, 2, and 4, -1. So notice this time, when we have a negative in front of the x squared, it basically flips everything upside down. So now it's facing downward. We'll discuss more about that with the next class. And the vertex is 2, 3. Okay, last example here. Notice we'll have an A of -1. And this does not have an x. That means we're missing B. That means B is 0. So our x coordinate of our vertex is going to be -b. Well, -0, there is no such thing, right? Over -1, so we just get 0. So whenever the B coordinate is 0, that means the x coordinate of our vertex is 0. Subtract 1, add 1, add 1. So when we plug this in, so if I plug in, now be careful here. Okay, it's -2 squared, which makes that positive, but then there's still a negative on the outside. So this will actually be a -4 plus 5, which is 1. Next, I have the opposite of -1 squared plus 5. So that will be -1 plus 5, which is 4. Plug in 0, so I'm just going to be left with 0, 0, 5. Sorry, I should be writing these here also. Plug in 1. So I should get 4. And then plug in 2. And I get 1. Again, we should see some symmetry. So these have to be the same and these have to be the same. So let's go ahead and graph it. We have -2, 1, -1, 4, 0, 5, 1, 4, and 2, 1. So this one also points downward, and our vertex was 0, 5.